Hello SGD, Sacred Geometry Decoded. I'll put the link in the description. This was a recent drawing exercise I did. Was one way of drawing a clock, and we created a 24 pointed star. The next drawing will be basically centered on the pentagram, but the question is, how do you make a 360 degree compass or the protractor? And well, we begin with a 24 pointed star, and we start 360 degrees divided by 24, which means each one of these points is 15 degrees. So 15 at 1 o'clock, 30 degrees, 12 divided by 360, 45 degrees and 60 degrees. Now I could have drawn a 48 pointed star, I just bisect each of those angles, but then the angle between them would be 7.5 degrees. So this began with a hexagon, and the smallest we can divide is into 15 degrees without now we're into half a degree. So how would you create a 360 degree? And so, well, the answer to that, well, the next step, so it's not quite the answer and it's a bit of a tricky question, but the next step would be to draw a pentagram. And actually, so we have a pentagram, and now we have to do an inverted pentagram, and then we sort of bisect those angles. We can break that down, and so that's what the topic of this drawing is. And we'll start with a construction line. And so the pentagram is going to take up like one. So the construction line, I'm not going to draw it in the middle. I'm going to draw it sort of 1/3 from the top, and so then 2/3 at the bottom. And try to fit it, how would I fit it in the page? But again, it's the same sort of idea. We're beginning with a Vesica Pisces and using some Pythagorean theorem, and it's a very simple construction. And then we can create like the next step in a 360 degree compass. So start with a Vesica. Okay, I've got room, I'm in camera. Okay, I'm going to start it over. Now, I only need the construction line on that side, so we begin with a circle, and then with a second circle. So, again, I don't want to stick my head in front of the camera to get the fine point, but if you do this, take your time, use a very fine point, be as accurate as you can. And now we, standard Vesica design, put your point where you want to go, use that to guide the ruler, and another construction line, cutting that down. So now we have 90, 90 and 90 degrees. Now it's not necessary to draw, I'm going to draw the entire circle now, because it will come in handy in later construction. So we draw this other circle. Now we also have a square, so 1, 2, 3, 4. The square would be at 45 degrees, but we also have the basics of a square here. But the important point now is that we have so let's just I'll call that A, B and C. That's 1, that's 2, therefore C to B line BC would be the square root of 5. So again, Pythagorean theorem. So I'm using 2 compasses because I don't want to change this one. And put the point on B, adjust the compass to C. So now if this is 1 from A, if AB is 1, then BC has to be the square root of 5, Pythagorean theorem. Okay, now I'm going to draw, you only need part of your circle, but I'm going to draw the whole thing because again it will come in handy in later constructions, and you sort of have this nice Egyptian eye thing that starts to emerge. But so now next step, not having changed the original compass setting, we go to the end, and again I'll draw the whole circle. It's we go to the edge there. Will it fit on the page? Yeah, but You don't actually need the whole circle, but again, it's handy to keep in because there's a lot of really cool fire related stuff in here as well, because if BC is the square root of 5 and if AB is 1, then I'll call that point D. So AB is 1, BC is the square root of 5, so BD is the square root of 5, so AD is AD is the square root of 5 plus 1, which is precisely phi over 2. Now, because this line bisects that, if I was to draw a line through it, this point there in the center would be precisely phi. So I'll draw that in just, actually, but cut that through there, then point A to E, I'm not going to write that in because I don't want to mess the drawing up, would be phi. AD would be 2 times phi, and AB is 1, therefore since that is phi, that means B to E would be 1 over phi. But all the points are there for the for your pentagram, and so we start at this point, and we'll also use this, and let's, so 1, 2, 3, 4, and A and D are going to be the defining points that we need. So I'll begin here, pen on the point, I'm going to go through where I marked it with that little circle, and where this circle is here, that's going to be where the line ends. So I've tested it on Geogebra, it's like 100% precise, so you're going to get a perfect pentagram, and now from that same point through this other one, and where it touches this circle. Okay, now we can go from D to A, and like 100% accurate, perfect, this construction. And now we just join up the lines and we have our pentagon. Now a pentagon 5, so 5 divided by 360 is 72. So you could say like the heart angle or the central angle of a pentagon or pentagram is 72 degrees. And what you'll find is that 36, 54, 72 and 108 degrees define all the inside points of a pentagram, or consider a pentagon. The inside corner angle is 108. Okay, now this point should actually pass through where that bottom point of the ellipse is there. So I've rushed this drawing. Okay, well, I'm not going to now, because I just want to show the basics of it and just get the point. So that should pass right through where those two circles intersect, so should that one, and it will terminate right on the end of the circle. Because I'm rushing it, the thickness of the pencil and all that comes into play, but follow the rules, test it on Geogebra, you have a perfect pentagon. Now in the later construction I'll show you what I mean, and I'll do it much more night. I just want to show the principle of it. And now we take our compass, and now I'm tempted, I'm going to go through that point a little bit. I'm going to change the line, and actually no I won't, because you can now just follow along. So from each point we're just going to draw a line going through the opposing trough. Okay, so where this dip is, where it comes together, we go through, and do a construction line that extends a little bit beyond. Okay, now from where the tip of that star go through and where it hits the trough, we'll extend that out. I'll put a link in the description. I've tested it in Geogebra, and like once or twice before I've drawn it, and again it's just a matter of taking your time and getting it all right. So now from this point, again where that goes through, and extend the line out a little bit on either side. And because what we're doing is we want to find the dead center of this pentagon. Again, thin point, like really take your time with it. I don't want to stick my head in the camera too much to avoid it. But you follow the rules and you will get the perfect one. Now the point is we want to start creating the next step in a 360-degree compass. And finally I go through there. Now you only need a few to find the center, but this will come in handy to make the next step, because now we want to do an upside down pentagon. Now I know my center's somewhere around there, and so now I want to find a point, and I'm going to set the compass to the tip of that star and draw a circle around it. Now this is a slight bit out because I didn't find the dead center, but okay, I want this circle to be really dark. I really want this one to stand out. And just to help highlight that, I'm going to extend it out a little bit just to create like so we can write the angles in. Okay, so we have our central pentagram, 5 divided by 360. So this is our center. So if this is 360 degrees or 0 degrees, the first point of that pentagram, 360 divided by 5, 720. The next point has to be 144 degrees. That one has to be 216 degrees, 72 times 3. The fourth has to be 288 degrees. All very lovely Pythagorean harmonic numbers. Now, as we found the center we passed through, we've also bisected each of those angles. So this has to be 72 divided by 2, so that's 36 degrees. 72, now we just add 36, so 36 plus 72 is 108 degrees. 108, well that's going through the center from 360, so again 144 plus 36 has to be 180 degrees. 216 plus 36 has to be 252 degrees, and 288 plus 36 has to be 324 degrees. Now we can, since it's already there, we can draw the inverted pentagram. So we have one with the top pointing up. Now I'm going to draw one with the bottom going down, and so I'm going to start at 36 degrees and go to 180, and then from 180 to 324, 324 to 108, to 252 degrees, and then from back to 36 degrees from 252. So we have now a inverted pentagram. What we really have is 2 pentagrams, and we've divided the circle up into 10. So there's a 10 pointed star there. Now the next step would be well, we can find the center. So again, we have these troughs or these deltas which are halfway through, and they will pass through the center. And so let's get a sharper pencil, so put it on the point where that chevron is. Set the compass up, find the opposite side, take into account the thickness of your, again if you use a really fine point, but still taking that into account, construction line through, and we just repeat that around. So the next chevron is here. That's going to pass through the center, and you can again align it with the chevron on the opposite side. Just repeat that all the way around. And so we've gone from a 10-pointed star, we've divided the circle into 10, and now once you've completed all the way around, you've divided the circle into 20 points. So 360 divided by 20 is 18 degrees. And all the construction lines already done one of them for us, so we have now 20 points around the outside. I just need to reset the computer so it doesn't mess up with the file. Okay, so we've divided the circle up into 20 points, and now it's just a matter of drawing another series of pentagrams in there, but we can already work out what those angles are because we bisected each section. So now we have 18 degrees, 36 plus 18, so that's 54 or half of 108. There we have 90 degrees, 126 degrees, 18 is 152, that's 162, 198 degrees, plus 18 is 24 to 34. 270 degrees, and 306 degrees, and then 32, 342 degrees. And now it's just a matter of drawing the next series of pentagrams, and it's just helpful to write in those degrees because now I'm going to start at 18, and I'm going to go to, let's make sure I get that right. That will be 230 to 234, over to 90. So I'm going to mark this out. I'm going to go A, B, A, B, A, B, A, B, A, B. So I just want to make sure, so all of the A's will form a pentagram and all of the B's will form a pentagram. So just once you start getting a construction like this, it's going to be a little bit tricky. So it's a matter of like 18 is A and 234 is A. Okay, now from 234 I go over to 90, which is an A. And then from 90 to 306. And then from 306 to 162. And and then from 162 back to 18. Okay, so that's the first. There's one more pentagram to draw, and that's we're going to use those 8 beat points, and we're going to have a 20 pointed start. So I start at 54, I go to 198, 198 to 342, 342 to 126, 126 to 270, and 270 back to 54. Okay, and there he is. We have a 20 pointed star. Now, just to keep it, because we still have that original, I'll leave that, but the one that was in, it's in light blue, if it's, you can make that out. So now we have a 20 pointed star. Now I can divide that one more time, but I don't need to draw the other pentagrams, because 18, I'm going to bisect 18 degrees and I get 9 degrees. After that, if I bisect it again, I would get 4.5. So we want to find full numbers. Now you can think about it, but again you get 4.5 when you try to add it. Trust me, there's using the standard polygons, there's no way to get around it. All of these numbers, well, firstly they're 9, so 1 plus 8 is 9, 3 plus 6 is 9. Actually the trick is that they're all divisible by 3. So just like with the 24 pointed star, we get 15 degrees. If I go to a 48 pointed star, I get 7.5. You can think, oh well, if I get 7.5 and the 4.5 from here, I can do. No, you won't. It's tricky. Now, so the next point is just to bisect. You know, again, use that chevron. Use one in the opposites. It'll go through the center, and that will be your final division. And so, for instance, if I start here, go through the center, I use the opposing chevron. What I'm going to have is 9 degrees, and over here I'm going to have 189 degrees. That's the smallest you can cut it. So now it's just a matter of repeating that all the way around. So you don't need, I've drawn a 20 pointed star, and now I'm just going to use bisects to get a 40 point division of 360 degrees. So 40 divided by 360 is 9. That's the smallest you're going to get. And so the next one would be 27 degrees, and what's that, 207 degrees. $171 degrees and 351. Again, 3 plus 5 plus 1 is 9. But the trick to all of this is it's 3 is the number. It's at 153 degrees and 333 degrees. Okay, so I'll go through here, through the center. Next one would be 45 degrees. Now, I could go all the way around, you get the point, really. Now, the issue is now, okay, so I have 9 degrees, that's the smallest I'm going to get, and I have 15 degrees, where I get from the 24 pointed star. So 9 and 15 is the 6 degrees, but the next one would be 18. And so if I was to overlay this on there, I would have 18 degrees, that would be smaller than that actually, and then I would have 9 degrees, so there's a 6 difference and there's a difference of 3. The thing is, if I was to add this drawing around the outside, the smallest division I get is 3 degrees. So if I was to incorporate this drawing into that one, I would divide the circle into 120 points, and so 3 degrees, 3 times 120, and so using this standard, easy to draw polygons, triangles, squares, pentagons and hexagons, the smallest I'm going to be able to break it up is into 3 degrees. So the next step is to find either 2 or 4, something that's not divisible by 3 degrees. For instance, 40 degrees, which is a nonagon. That would be the next step. But so again, it's just if I could dress this up and sort of do, there's all sorts of styles if you want to draw that in, if you want to carry it through. So just as a drawing exercise, as an artistic sort of enterprise, this is another construction, because this one began with an equilateral triangle 3, then a hexagon 6, then a 12-pointed star, then a 24-pointed star 3, 6, 12, 24. This began with a pentagon 5, then a 10-pointed, then a 20-pointed, and then a division of 360 into 40 degrees. So the next step is basic, like what I have to do is find 4 degrees, because the smallest I can break it up is 3 degree sections. And if I did a square, so 90 degrees being the heart or the central angle of a square, you can divide it into half again, and then you get 45. And both the pentagon and design, or this hexagon will also give you 45. So it doesn't help to bring a square into it at all. And then you get into the 7-sided and so now the trick is, how do you find 4 degrees? So we have incorporate this with that. I could break it down into 120 points, or 360 divided by 3. Again, gives you a 3 degree point. So the next step would be incorporate this into that, but then to find a 4 degree, or something that's not divisible by 3. So whether it's an 8 or a 16 degree angle, doesn't really matter. It has to be shifted either 1 or 2 degrees from 3. Now once you get to 120 divisions, you could sort of eyeball it and try, and do an approximate of trisecting the angle. But we want to stay with as much pure geometry as we can. And so the real next question is how to draw a nonagon. And well, technically speaking, it's impossible to draw a nonagon with compass and straight edge. So technically speaking, using this sort of Euclidean style, you can't divide the circle up into 360, but I'll show you a nonagon, which is I think it's the most accurate one going out there. The margin of error is so small that even with the finest pencil, you're still not going to come anywhere close to near that margin of error. But technically speaking, it won't be perfect, but in any sort of real world application, drawing it even on a giant circle, the margin of error is thousandths, only a few thousandths of a degree from perfect. So drawing exercise, again, also draw it neater. You can, all sorts of nice geometries will appear from there. I'll put the link in where I tested it on Geogebra, the original pentagram as well. So this is geometrically perfect if drawn correctly. This is geometrically perfect if drawn correctly, and you start to get all these again the Pythagorean tuning and harmonics. These are the numbers that you'll find in all sorts of religions really across the world, but embedded in modern architecture and other features as well. And okay, I'll do that because 33 degrees, which you'll be able to draw, 153 degrees, and 273 degrees. I'll put the link to, I did a whole series and I've compiled it together into 2 parts on the importance of the angles of the pentagram, and just how much as a mnemonic, but also links to astronomy, beautiful mathematics, and again Pythagorean tuning and all these types of things as well. Alright, so pentagram design divided 5 and then a 10-pointed star and a 20-pointed star gives us the division of 40, and 9 degrees being the smallest that we can do without going into a half degree. And the 24-pointed star, I'll link this in the description as well, and the smallest we can do is 15 degrees from there. Alright, just another drawing exercise, but we'll be leading into how to create a almost perfect 360 degree compass. That sort of relates into the earlier drawing I did. Yeah, that's a 32 point compass rose. I'll link that in there, but 32 divided by 360 does not give you whole integers. You know, it's still, you end up with fractions of a degree, but we want to turn a clock into a compass, and that comes again from the essence of Euclidean geometry. And triangles, squares, pentagons and hexagons are just 2 triangles as well, so there's only really the 3 triangle, 4 the square and 5 the pentagon. This is just a extension of that where you start bisecting. Alright, yeah, okay, next drawing will be in there. Cheers and have a good one.